Okay, let's have a go at doing a couple of applications of Pythagoras' theorem to situations that aren't right-angled triangles immediately. Now, the first thing we always need to do, or one of the early steps, is to identify a right-angled triangle, okay? So this is going to be our right-angled triangle. We're after x here. Now, if we extract just the part we're after now, okay, if we, first of all, before that we'll do that, this part here, this line here, must be 20 because it's parallel and right angles there, okay. That leaves this to be, this portion to be 16, 36 minus 20. So now we can extract our triangle. Sorry about my dodgy drawing there, so that's 16 there, it's very poorly scaled. That's 10, and this is x. So now we just have a simple right-angled triangle where we're being asked to find the hypotenuse, okay? And as we know from the previous exercise, c, or in x in this case, will equal the square root of a squared plus b squared, in which case a is 10 and b is 16, so the square root of 10 squared plus 16 squared, x equals the square root of 100 plus 16 squared is 256, x equals the square root of 356. We get a calculator out and we find that the square root of 356 is plus or minus 18.87. Now obviously it's because it's a length of a side, it's a positive. Okay, so that's in millimetres. Okay, the key really is finding the right angle triangle within that original drawing. Okay, now let's have a look at the second example. This is an isosceles triangle, and we may be asked to find the height. We might also be asked to find the area of the triangle. Okay, so first of all, we put a line straight down the middle there. And we know now that this will be a right angle, and we can see that we have one right angle triangle here. That is 15. That is h that we're trying to find, and this is half the base, so that is half the base of the original triangle. Okay, so this is 9. Okay, so now we have the situation where we are trying to find one of the shorter sides, and as we saw earlier, that would be, say, a squared equals the square root of c squared minus b squared. So in this case, whoops, not a squared, just a. So instead here, a is h, c is 15, so 15 squared minus 9 squared equals 225 minus 81 equals the square root of 144. We know without a calculator, hopefully, that is plus or minus 12, or in this case we just want 12, positive 12. Okay, now if you're also asked to find the area of the original triangle, okay, we would know that the area equals a half times the base times the height, and so that will be a half times, now the base was 18, the height as we've just found is 12, we multiply those out, we find that that is 108 millimetres, let's say it's millimetres squared. Okay, thank you.